This is Algebra 2, Unit 9, Lesson 7, and today we're going to put a lot of information together that we've learned in this chapter to graph rational functions. Rational expressions are expressions that include variables that are fractions. Rational functions are functions that have an x and a y that can be graphed with a numerator and a denominator, and also include variables. So in this one, what we're going to do is we're going to put everything together that we've learned. We're going to use our knowledge of horizontal asymptotes, vertical asymptotes, and holes, and x and y intercepts, and then we're going to take that information and graph it on a coordinate system, and then we're going to use Desmos to kind of help us fill in the gaps so that we don't have to do so much by hand. It used to be that we would do this by hand, and then we would use a calculator to kind of fill in the other ordered pairs. But now that we have Desmos, Desmos makes it a little bit easier. But we do still need to be able to find horizontal asymptotes, vertical asymptotes, and holes, as well as x and y intercepts by hand, because especially with the asymptotes, Desmos does not necessarily do that very well for you, and so you have to have that knowledge and you have to be able to do that by hand to get some of those correct. So that's what we're going to do here. We're going to do 3 examples. For each example, we will do everything by hand that we can and start a rough sketch of a graph, and then we'll go into Desmos to finish our graphs off. So it's not necessary to do all of this by hand. It can get quite tedious if you try to do that. So it's a little bit easier going this route and then using Desmos to finish it out. So to start this one off, the first thing I always do is I find horizontal asymptotes, because you don't need to do any work really to find those. Remember, with horizontal asymptotes, if the degree of the top is less than the degree of the bottom, then your horizontal asymptote is y equals 0. And that's what we have here. The degree of the top is 0, the degree of the bottom is 2, so the top is less than the bottom, so our horizontal asymptote is at y equals 0. Our vertical asymptotes are found, and our holes are found by factoring this thing to see if anything will cancel out. Now, if you factor the top, it won't factor, so there's nothing you can do there. If I factor the bottom, factors of 6 that subtract to give you 1 are 3 and 2. You have a plus 3 and a minus 2. Nothing there cancels, so that means this function will not have any holes. So for the holes, we're going to say none. For our vertical asymptotes, those are going to be found by setting the factors in the denominator that did not cancel out equal to 0. So we have x plus 3 equals 0 and x minus 2 equals 0. To solve that out, we have x equals negative 3 and x equals 2. So for this one, we have 2 vertical asymptotes, and there's nothing wrong with that. You could have 2. You could have more than 2. Usually you have 1 or 2 with the examples we'll be doing. So we've got x equals negative 3 and x equals 2 as my 2 vertical asymptotes. The next thing we have to do is find the x and y intercepts. Remember, to find the x-intercept, we will set y equal to 0. To find the y-intercepts, we will set x equal to 0. So, to find the x-intercepts, I'm going to set y, or f of x, equal to 0. So we have 0 equals 6 over x squared plus x minus 6. When I multiply the denominator over, I get 0 equals 6. Well, that's not true. That's not going to yield any x-intercepts. So we have no x-intercepts here. This does not cross the x-axis. And that'll make more sense when we get into graphing. You'll see why. For the y-intercepts, we're going to set x equal to 0. So when we do that, I'll just stick it right here. F of x, or y, equals 6 over 0 plus 0 minus 6 is negative 6. So f of x, or y, equals negative 1. So our y-intercept is negative 1. And that would be an ordered pair, 0, negative 1. The next thing we're going to do is start graphing these. Our horizontal asymptote is y equals 0. Y equals 0 is the x-axis. So what I'm going to do here is I'm going to dot this line, make it dotted. When I make it dotted, that signifies that is a horizontal asymptote or a vertical asymptote. So dotted lines are asymptotes. So this is now a dotted line, letting me know that when I look at that graph, that's an asymptote. The graph is not very likely to cross that. Now remember, it's possible for the graph to cross the horizontal asymptote. It doesn't usually happen, but the thing that you have to know about that is that at some point on the graph, our line or our graph will approach that asymptote. Okay, now we know that it's not going to cross this one because we had no x-intercepts. Okay, so we've already figured that out. It does not cross that horizontal asymptote. Graphs can't cross the vertical asymptotes, but sometimes, very rarely, they will cross horizontal asymptotes. Vertical asymptote is x equals -3 and x equals 2. So at x equals -3, I'm going to have a vertical asymptote. I make that a dotted line because it's an asymptote. It's something that the graph will approach. And at x equals 2, I make another dotted line for an asymptote because that's something, again, that my graph will approach. So if you look at this, we have 3 sections of this graph that we're going to need to figure out what happens. We have the portion to the left of the asymptote x equals -3. We have the portion between the two asymptotes from x equals -3 to x equals 2. And we have the portion to the right of the x equals 2 asymptote that we're going to have to figure out what happens in each of these sections. And the domain of this function is all real numbers. So there will be something in every part or every portion of that graph. The next thing I need to do for this also is I need to graph my y-intercept. My y-intercept is at -1. So once I get all this done, that's all I can do by hand. The rest of it needs to be done on Desmos. And then I will generate this graph on the computer so that you can see how we finish this off using Desmos. Okay, so I've redrawn the graph on the computer screen. You can see here in the blue dot is the y-intercept. We've got a horizontal asymptote on the x-axis, which is at y equals 0. We have 2 vertical asymptotes at x equals -3 and at x equals 2. I've tried to color code it a little bit so that you can see what's happening. Next, I'm going to go to Desmos, and we're going to look at Desmos and see what to do, where to draw the rest of my screen. I'm thinking that we're going to have something in here, and that we're going to have something up here and up here. The only reason I know that is because I've done a lot of these types of graphs, and that's normally what happens. So let's go to Desmos and see what it says, and then we'll go from there. So here is the graph on Desmos. You can see right here, that would be the ordered pair 0, -1. You can see this graph it approaches the x-axis, but it never crosses the x-axis, never touches the x-axis. It's just getting very, very close to the x-axis on both sides. Right here, you can see that it's approaching the x equals 2 line. It approaches the x equals -3 line on this side, and it does the same thing on this little parabola looking portion of the graph. It's not a parabola, but it looks like one. It's approaching the x equals -3 here, and it's approaching the x equals 2 line here. So you can see how Desmos approaches the asymptotes. You can also see that asymptotes are not labeled. So unless you know how to do that by hand, you may not be able to tell where the asymptotes are going to be happening. So it's very important to understand how to do that portion by hand. So going back to my notebook, if I were to draw this graph, I would go right here and I would draw my line approaching the vertical asymptote here. I would draw my line approaching the vertical asymptote on this side. Up here, I would make sure at 3, 1, we had a dot on the graph, and it approaches the asymptote on both sides as we go through there. So that's a good estimate about where that graph would be, or that side of the graph would be. And over here, I need it to go through -4, 1. So I'm going to approach from this side, try to go through 4 or -4, 1 as close as I can, and then approach the asymptote from there. So this is a good estimate of what the graph should look like. If I ask you to find the asymptotes and actually draw the graph by hand, that's what I would do. If I don't ask you to do that and I just ask for the asymptotes, the horizontal asymptotes, the holes, that type of thing, then I would just find those by hand and use Desmos to estimate where the graph would be. That's going to be your easiest option. This graph did not have any holes, so we don't have to worry about that. The next one we will have some holes in the graph, and we'll talk about how that is supposed to be graphed by hand as well. Here's the second graph we're going to do. We're going to start it off by hand, just like before. The first thing I always do is find my horizontal asymptotes. So to find the horizontal asymptotes, I have to compare the degree of the top with the degree of the bottom. Both of those have a degree of 2. When the degrees are the same, remember your horizontal asymptote is y equals the ratio of the leading coefficients. The ratio of the leading coefficients here would be 1/1. So our horizontal asymptote is going to be y equals 1. For our vertical asymptotes, the first thing we're going to do is we're going to factor this to see what's left on the bottom and what needs to be set equal to 0, and see what cancels out. So remember, things that don't cancel from the bottom will be vertical asymptotes. Things that do cancel from the bottom will be holes. So I'm going to factor first. On the top, I'm going to factor out an x. That leaves me with x plus 2. On the bottom, factors of 6 that add to give me 5. That would be 2 and 3. Both of them are the same sign, and they're both pluses. And then if you look at this, you can see that x plus 2 does cancel out. If that cancels out, that means that's a hole. If we set the one that canceled out equal to 0, we have x equals -2. So that means we will have a hole in the graph at x equals -2. Now, it is possible to sometimes have more than one hole. Usually you only have one, but there's nothing that says you can't have more than one, okay? For the next one, the factor here that did not cancel out is the x plus 3. And so my x plus 3 is set equal to 0, giving me x equals -3 as my vertical asymptote. So that would be my vertical asymptote. The next thing I have to find is the x and y intercepts. To find the x-intercept, I set y equal to 0. So if I set that equal to 0, 0 equals x squared plus 2x over x squared plus 5x plus 6. If I multiply the denominator over, I'm going to have 0 equals x squared plus 2x. If I factor this, I take out the x and have x plus 2. So that gives me two answers, x equals 0 and x equals -2. So that means we have two x-intercepts here, and there's nothing wrong with that. We can have more than one root, right? The roots are where it crosses the x-axis, or the solutions, or the x-intercepts, or the zeros are where it crosses the x-axis. So we have two of them here, x equals 0 and x equals -2. And then for the y-intercept, we will set x equal to 0. So y equals, and if I set all the x's equal to 0, I'll have 0 on top and 6 on the bottom. Well, 0 divided by 6 is just 0. So our y-intercept is at 0. Then I'm going to do my initial graphing. My horizontal asymptote is at y equals 1. Remember, horizontal lines go across the graph, so we have a horizontal line here at y equals 1, and that horizontal line is understood to be an asymptote. That's why we make it dotted. The vertical asymptote is at x equals -3. So I'm going to make a vertical dotted line at x equals -3 to signify that that's a vertical asymptote. I will have a hole at x equals -2. Now, holes can't be graphed until the very end of the problem. So we will get there, we will graph that hole at the end after we've looked at Desmos. And you're going to see that with Desmos, it may not graph the holes. Okay, so we have to be really careful about when we're graphing these on paper and understanding where the holes are, because a lot of times your calculators and your Desmos are not going to necessarily graph holes. So we have to understand where they are and how they should be graphed. That's why we're doing some of this by hand, because the calculator and Desmos do not necessarily do all of this for us. And when we have our standardized tests at the end of the year, they're checking to make sure you know how to do this without a calculator, because the calculator is going to leave a lot of this stuff out. And without Desmos, because Desmos is going to leave a lot of this stuff out. So you have to understand what happens at these significant portions of the graph. For this graph, we have two different portions. We're going to have something happening on this side of the vertical asymptote and something happening on this side of the vertical asymptote. We just have to consult Desmos to see exactly where the graph is going. So the next thing we need to consider is where our x and y intercepts are. And this one's a little bit tricky, so we need to really think about what we're doing here. When we found the x-intercepts, we set y equal to 0. And when we did that, we ended up getting 0 and -2. Well, there's a problem with this, because up here, didn't we learn that x equals -2 canceled out, and that we have a hole at x equals -2? So since we have a hole at x equals -2, since that function is undefined at x equals -2, because at -2 we have a 0 on the bottom, making it undefined, we can't say that x equals -2 is an x-intercept. So this is kind of a special case. We need to get rid of that one, because we're going to have to look at Desmos and see what happens at x equals -2. And when we get to x equals -2, we're going to have a hole there wherever that graph ends up. So that's one of those things that you're going to have to pay special attention to, because it appears up here or down here when we factor it and we find the x-intercepts that we have two x-intercepts. But because the function is undefined at x equals -2, we cannot say that that is an x-intercept. So I have to throw that one out, because we don't know what's really happening there. It ends up being a hole, okay? So I threw that one out. So when I go to graph my x-intercept and my y-intercept, if you'll notice, they're the same. So that just means it crosses the x and y axis at the origin. Okay, so even though this one appeared to have two roots, in fact, it doesn't, because that x equals -2 is a special case. It's a hole in the graph, according to the work that we did. This is why it's good to find your asymptotes and holes first, so that when something like this happens, you can see where your special cases might be. And again, Desmos is not necessarily going to find that for you. That's what you have to do by hand, so that you don't miss that when you're doing the final graphs. So now that we've graphed what we can by hand, we're going to go to Desmos and finish this one off and see what happens. So in the second example, I've put in the asymptotes and the x and y intercepts. Remember, in this one we had a horizontal asymptote at y equals 1. We had a vertical asymptote at x equals -3. And the x and y intercepts were both at 0. So I've graphed that here. We know that the graph is going through here. My guess would be that it's going to approach the asymptote in this direction, and then again in this direction, and then we're going to have another one here, because usually with your graphs of rational functions, they are diagonal from each other. And so this one's not going to be any different. The one thing I do want to point out here, though, is that this one did have a hole, and we need to make sure that we're noticing that when we're talking about Desmos, holes aren't going to show up in Desmos. So we have to know how to make sure we're putting all of the information into our handwritten graph. So that's what we're going to concentrate on with this one. So I'm going to slide over to Desmos so that you can see how Desmos graphs this, and we'll make some comparisons as we do our own graph. So you can see here that I have Desmos graphed. I've got the equation here, and you can see that the graph of Desmos Y equals 1 was our horizontal asymptote, and you can see here that the graph is approaching that line y equals 1, but it did not put that y equals 1 or that asymptote into the graph itself. Another asymptote was at x equals -3. It's not showing up here, so in order to understand that that asymptote is there, we would have to be able to find that by hand. It does put the intercept in there for us, so that's nice. Notice that we determined that there was a hole at x equals -2. It's not an asymptote, but a hole. And notice here at x equals -2, Desmos does not put that hole in there. So we have to physically put the hole into the graph where it belongs. So when you're tested on things like this, they're going to ask you to find your vertical and horizontal asymptotes and holes by hand, because graphing calculators and online graphing calculators are not going to do that for you. So that's a way they can test to make sure you understand what you're doing, even though some of those things aren't going to be showing up on the technology that you're using. So I'm going to go back now to the notebook, and we're going to look at the graph on our own, and it is diagonal like we said it would be. So we're going to make sure that we're going to put a hole at the x equals -2, and that we draw our graph through the intercept, and that we make this one approach our asymptotes in the notebook. I'm making sure that I'm very close to the asymptote. I go through my intercept. I continue down. Right here at x equals -2, I know that I have a hole. So I'm going to draw the hole in there, and then I'm going to continue my line so that it approaches my vertical asymptote x equals -3. So that's a good estimate. So that's a good estimate for what the bottom portion of the graph would look like. For the top portion of the graph, I'm just going to draw my line here and approach both of those asymptotes. So that's a good estimate of what our graph should look like. So here's our final example. In order to find the horizontal asymptotes, again, I need to look at the degrees. Again, here the degrees are the same. If the degrees are the same, then your horizontal asymptote is y equals the ratio of the leading coefficients. The leading coefficient here is 1. The leading coefficient here is 1. So our horizontal asymptote is y equals 1/1 or 1. For our vertical asymptotes and holes, we're going to factor. So if I factor the top, factors of 3 that add to give me 4 would be 3 and 1. They're the same sign and they're both minus. On the bottom, factors of 2 that add to give me 3 are 2 and 1. That tells me they're the same sign as this, so they're both minus. And here the x minus 1 cancels. Since x minus 1 cancels, that's going to be a hole at x equals 1. So we have a hole at x equals 1. And then the x minus 2 does not cancel, so that's where our vertical asymptote would be. If x minus 2 equals 0, x will equal 2. That's my vertical asymptote. The next thing I'm going to find are my x and y intercepts. To find the x-intercept, I set y equal to 0. When I set y equal to 0, remember, 0 equals all this. The denominator is going to cancel out because I multiplied over to 0. So what I really have here for my x-intercepts is 0 equals x squared minus 4x plus 3. And if I factor that to find my x-intercepts, I end up with x equals 3 and x equals 1. But remember, we had a hole at x equals 1, so we're going to have to throw that one out. And we're going to have to say that our x-intercept is at 3. And that would be the ordered pair 3, 0. My y-intercept is what I get when I set x equal to 0. So if I set x equal to 0, I have y equals 0 minus 0 plus 3. So 3 over 0 minus 0 plus 2. 3 over 2. So y equals 3 halves would be the ordered pair 0, 3 halves, or 3 halves is 1 1/2. So to graph my intercepts, the x-intercept is at 3, 0. The y-intercept is at 0, 3 halves, or 1 1/2. My horizontal asymptote is at y equals 1. My Vertical asymptote is at x equals 2. And I know when I draw my lines or my curves for this, I will have a hole at x equals 1, but I'm going to have to go to Desmos at this point to finish this problem off. For example 3, we found that we have two asymptotes, one at y equals 1 and another one at x equals 2. We said that we had a hole, I believe that was at x equals 1. So when we get to the graph for x equals 1, we will need a hole in the graph. We had intercepts at y. The y-intercept was at 3/2 or 1.5. And we had an x-intercept at 3, x equals 3. So I've got all those things graphed. We're going to move over to Desmos and look and see what Desmos says the graph would look like. So here is the Desmos graph. You can see the y-intercept is at 1.5 or 3/2. The x-intercept is at 3, like we had said. Notice they do not have the asymptotes drawn in here. We have to understand that this x equals 2 is an asymptote. We can see that it's approaching the asymptote on both sides. We see that the y equals 1 is an asymptote, and both parts of the graph are approaching that x equal or y equals 1 line. We do know that we have a hole at 1, but notice the hole is not showing up here, so we will have to physically put that hole in the graph when we draw it by hand. So for this portion of the graph, I know that my graph approaches the y equals 1 line, goes through my vertice or through my intercept, and then approaches again this line on this side, the asymptote on this side. And for this portion of the graph, I know that my line will approach the asymptote from that side, go through my intercept, and approach the vertical asymptote here. I have a hole at 1, so I'll just draw that in the best I can and continue up in that direction. So there's a good estimate for what your graph should look like.